Hello everyone. So in this lecture we'll be understanding how to use native assets and transfer them from one node to another node, right, without actually interacting or doing anything on the blockchain. So it will be just a transaction, right, which will be executing, and the asset will be transferred from one node to another node using the command line. So first question is like, what are assets, or what are the native assets, and how it is related to blockchain. So simply the multi-chain allows the creation and tracking of the assets at the network level. So this is an interesting use case of blockchain to have defined limited native assets and let the peers or node transact them among each other, right, in an atomic manner or in an non-atomic manner. So it depends. So you can define. Now the question is, how will you relate the asset which are being represented in the blockchain, right, with your real life use cases, right? So it can be anything actually. So you can convert anything and count any your business entity, or anything in your business as a asset. So let's say, it can be a resource R, right? It can be a real currency. It can be like, for example, in the case of the bank, it can be a real currency, right? So how much money the bank owns, right, at a certain moment type, or when the first block has been mined. So it will become a real currency as an asset, right? Or it can be a virtual currency, like, what the Paytm in the India, they have a mobile wallet. So how much money virtually they have in their wallet, and when somebody is transferring the money from one person to another person, it can be actually tracked and using the blockchain. Also it can also be, a CPUR, for example. It can be a virtual currency like Bitcoin. It can be a fraction of Bitcoin, or it can be even other virtual currency. So it depends on business to business how you define your asset, right? It can be anything. So assets are nothing but a representation of an asset, right? And you can actually transact them from one node to another node, or let's say one address to another address, and make the business use cases of it. So let's say, for example, in this case, let's say logistic company, logistic management company, right, a supply chain management company, something like that. They have, like, say, one consignment is equal to one asset, right? And they have a certain node which are defined, which can actually create the assets. Whenever the new consignment is booked by a company, they can create the assets. And when the assets has been created, yeah, right, so every branch will have a different servers, where this asset will be transferred from one server to another server. It means, or one address to another address. It means that, node is being transferred from, sorry, the asset is being transferred from one branch to another branch. You can represent a branch using the address. So these are the kind of use cases that you can define and create your own. So whatever you want to build, it's all up to you. You can imagine whatever you want, and possibilities are endless. So in step one, what we need to make sure that we are connected to the both the servers, right? So as you can see that we have this node 1 connected as well as node 2 connected in the interactive mode. So please switch to that if you are not. And then we will start with the native assets in the multi-chain. So this reference has been taken from the multi-chain website. The multi-chain supports asset natively at the blockchain level. The identifiers and the quantities of the assets are encoded in each transaction output, along with the quantities of the blockchain's native currency, which may be zero if it is not being used. So it means that whenever the inputs are coming, it are actually encoded, and sorry, when the outputs are going from the transaction, the transaction has an input as well as output. So whenever the transaction, assets are being shown in the output, they are actually properly encoded. Every multi-chain node tracks and verifies the quantity of the assets in the transaction, just as it does in the native currency. So uh, this is a very important part, that total number of assets in the blockchain should remain the same, right? Not anybody can actually create the assets out from the thin air. So out of thin air. So until unless there is a node which has the power to issue the assets, can only actually issue the assets. So this kind of features are all available in the multi-chain. So admin can only issue the assets. You can call it a head office. They are actually allowed to issue the assets. Or let's say a particular server, right, or a node which will issue the assets only if the cash actually is being received by the company. So this kind of logic can be created. Specifically, when they does transferring the native currency from here to there, right, the asset transferring from one node to another node, it actually checks the total quantity of all the assets in a transaction output are exactly matching the total assets in the input output. So ऐसा नहीं होना चाहिए कि something like you are losing the value or losing the assets. So this kind of thing should not be done. Multichain also allows each transaction output, right, can contain different number of assets. So you can define five different type of assets, because let's say for e-commerce company, uh, let's say you want to have 1 lakh products using in your company. Yeah, your company is selling, so you can have 1 lakh different assets. So this is in fact possible in the multi-chain. So for every product you actually buy from a actual vendor or bring it on board, you actually define it as an asset. So you can calculate how many let's say mobile phone you have in your e-commerce system by using the assets in the multi-chain. So that can be done. So in fact the e-commerce industry can be revolutionized, but the problem is that it takes time for the people to understand and implement the use cases and build the technology. This technology is quite new, so people are still building it. So multi-chain is a very good option for that. In multi-chain, the assets are actually being recognized by the three things, right, or any of the three things. One is the optional asset name, so you can define any asset's name. It can be any 32 byte size case sensitive string, right. Second is the issue transaction ID, so the transaction ID using which the asset has been issued, so you can recognize the asset on using that as well. And next is the asset reference, so it is an encoded block number, right, encodes which encodes the block number, byte offset of the issuing transaction along with the first two bytes of this transaction ID. So if three things are merged, you can have a asset reference. So I'll show you what asset reference look like in the upcoming screens. So if you want to learn more about the assets in the multi-chain, please I'll ask you to go to the multi-chain website and refer it. You can also check out the multi-chains white paper to understand more. So what we are going to do is we are going to first check out in the node 1 that what is the list issue permission has, who has the issue permission to create the assets. So as you can see, there is only one address in that. It means this address, as we are aware that this address, which we call it a LDFG, right, LDFG is owned by node 1. It means only node 1 has the rights. Of course we are aware of this because we haven't given any rights to the node 2 to issue the assets. So here the node 1 will actually can initialize the assets, can create the assets, and can issue it to the system. So let's try to issue the assets, right. So let's try to issue the asset. So I'm going to use the issue command, right, my address name, right. So I'm going to issue some, let's say 1000 units to myself, right, with the asset name as asset 1, right. So I'm going to use asset 1 and then 1000, and the the unit, the parts, the subdivided parts will be 100. So I want to use 0.01. I can use it, sorry, I can use it to 0.001 or 0.00001, just like in Bitcoin. There are, very small fraction can be possible. So remember, we are going to issue asset 1, which is the name of the asset. This is the name of the asset. This the way we are talking about the asset name. So we are going to use the asset 1 as an asset name and going to issue it to ourselves. So yes, so as you can see that asset has been issued, the transaction ID has been returned. So if you want to check out that how many assets are available in the system, you can use list assets command. So if you list assets command, you can see that the name of the asset, the issue transaction ID which I was talking about, right, how the asset is being recognized. So this is the transaction ID using which the asset has been issued. As you can see that this is matching with this one, which was correct, right. Second is the asset reference. This is what we were talking about. This is how the asset looks like, can be represented. Remember, we issued the asset in the node 1. So let's check out the status of the assets in the node 2, where we didn't do anything, right. So we need to understand whether this node has this information. Oh good. So now as you can see, the asset has been already propagated to node 2. This looks very easy and very obvious, yeah, this is, but just imagine the screens are actually next to each other, right? That's fine. But just imagine one node is actually situated in Germany, and another node is situated in USA, and another node is situated in Australia, and another node is situated in Japan. And just imagine you issue an asset using the Germany's node, and within a fraction of second the other nodes has the information automatically over the internet. So how beautiful is that, right? Because everybody is synced and decentralized, so everybody is aware of it. So if you shut down the Australian server, right, other servers will not be affected, their functionality will not be affected. So this is the beauty of decentralization. So you can check the asset balance on the e-server, and also you can the check the total balances, right? So this actually showing the detail of the assets, right, but not the balance. So let me check out the balance. Let me go to the node 1 first and then check the total balance. So as you can see, we have this asset 1, asset reference, and quantity is 1000. So let me go to this total balance, and yes, there is no asset because we issued the asset 1 to only node 1, not to node 2. Right now it's time to send an asset from node 1 to node 2, right? Right. And let's transfer the 100 units, right? So send assets to the receiving address. So receiving address, that we have the node 2 address already with us. So I'm going to just copy the receiving address. So I'm going to send to node 2, right? um, so we'll say send asset node 2, name of the asset, and then quantity, right, whatever you want to transfer. So I want to transfer 100 units to node 2. So we have this transaction ID. Remember, we send this from node 1. So let's try the and get the balance. So let's first try to get the balance on the node 1. So let's try node 1, what how much balance we have. Okay, we have now 900 quantity. Earlier we had 1000, right? So we have 100 quantity less. Let's check it, the balance. Earlier it was 0, right? Let's check the balance here again. Okay, so now we have 100 quantity here. So we transferred 100 quantity from this balance, from one address to another address. So that's beautiful, very easily done. To just to imagine that if you want to create your own blockchain using some software or blockchain, so it will take lots of time and efforts to do this, but multi-chain is making it so easy for everyone to install it and build your applications. So this is how you send the assets, right? So remember, I'm going to actually see the asset transaction, right? So there is something called asset details. So get total balance 0 means you want to see the balance even if the confirmation is not there, right? So let me see that there is a transaction detail list wallet transaction. So I'm going to see the list wallet transaction and see what happened. Let's try this in node 2. So this will actually give you the list of transactions that has happened, right, on this wallet. So as you know that in this wallet we received this node, right, asset 100 quantity, which has been executed like this. So you can see that you have a asset which has been shown as this was the my address, this was the other address, right? And then confirmation means how many blocks this transaction has been recorded. So it has to be recorded in at least one to count it as confirmed transfer, because one block at least must record this as a transaction, otherwise it will not be counted as confirmed. So this has confirmed this is the block hash where the everything has been recorded, other information, transaction ID, and everything is available. Similarly, if you will go to node 2 and try to execute this command, you will see multiple transactions, not just one. Yeah, sorry, in the asset we have transferred only one, so that's one you are seeing. So that's it. So this is like, and yes, this is a 100 minus 100 transaction. Remember, here we had 100 plus, and here we had 100 0, and this address has been changed, right? So see, now confirmation has been increased to 10. So this will keep increasing actually. So transaction is will keep increasing. So now second is that how to make a transaction with the metadata. So when you send a transaction, you can actually or execute a transaction, you can actually also add some metadata into the transaction. So I'm going to do is, so I'm going to send again this 125 assets. So from node 1 to node 2 with some metadata. So I have to use something like this as a JSON, right? So remember, you can use multiple assets to transfer in a one single transaction, as which is possible in multi-chain. So you can use multiple asset values, asset name and the value, asset name and the value you want to transfer. So I'm going to use this send with data command from node 1, right, space the receiving party. So receiving party is this second one, right? This is the second node. So this is the receiving party, means node 2. And of course we want to transfer 125 nodes with some this metadata. So I'll just copy this from here, right? So this will transfer asset 1, right, into node 2 with some this metadata, right? So let me execute. Yes, transaction ID is given. So as you can see that, so let's check the total balance. Get total balance. As you can see, it has been again increased. 125 minus has been done. If you'll check the list of transactions, right, you can see that 125 has been shown, right, and the confirmation has been received for this transaction. So I'm going to check the balance here. This balance has been, as you can see, that balance 125 has been increased, right? So let's check the wallet transaction. So I'm going to copy this get wallet transaction and with the transaction ID, right? Get wallet transaction space the transactions. When we transferred the money, sorry, the asset 1, this was the transaction ID. I'll copy this and I'll come here and I'll paste it. Oh, sorry, done 2 times. I don't know where to end. So I'll just enter this. It will show some error, and we'll say get wallet transaction space and paste. Right. So as you can see, I have entered the get wallet transaction detail. So this was the complete detail, and here you have the data. So this data will contain whatever the metadata you are going to send. You can send any size of metadata, right? And it will be shown here. So this is like attaching some extra information while transferring the assets, some meta information. So that is possible. So that's it. That's it for this lecture. If you have any question, please ask.